Hello class, this is going to be our flipped classroom on mole to mass stoichiometry. Now we first did one on mole to mole. This one is very similar, except it's going to require two steps instead of just one. You'll be asked to calculate the mass of either a product or reactant, and you're going to be started with some information about the moles of either a product or reactant. So the first step is the exact same thing as we did in the previous video for mole to mole stoichiometry, which is using moles of one thing, you're going to set up a proportion to find moles of what you really want. So let's once again use an example. 4 moles of NH3 plus 3 moles of O2 will yield 2 moles of nitrogen and 6 moles of water. I'm going to start by giving you 2.5 moles of ammonia. So remember, the ratio is 4 to 3 to 2 to 6, but I'm not going to give you 4 moles of ammonia. I'm going to start with only 2.5, and all I'm interested in is how would you find the mass of the water produced. So to make this more clear, I'm giving you ammonia, and I want to know when the reaction is over how much water I'm going to make, which means I don't care about the oxygen, I don't care about the nitrogen. These are the only two things I care about. So what do I do first? Same thing we did in the previous video. Starting with the moles of ammonia, I'm going to find the moles of what it is I want to find, the water. So I'm going to set up a ratio, and this is what it's going to look like. So I know that the ratio between the ammonia is 4 to 6 between ammonia and water. So I'm going to do 4 over 2.5, because that's what I was given, is equal to 6 over x. And that's what I have right here. 4 over 2.5 equals 6 over x. 4 moles of ammonia is to 2.5 moles of ammonia, as 6 moles of water is to how many moles of water? So when I cross multiply, I get the answer to be 3.75 moles of water. You can see the math there. 4x is equal to 15. Divided by 4, I get 3.75. However, that is not the final answer, because as you can see, that is the moles of water, but I didn't ask for the moles of water. I asked what is the mass of the water I'm going to produce. But since we already know the moles of the water, all we have to do is convert moles into grams, and we know how to do that. We use the factor label or the 3-line method. We convert moles to mass by simply multiplying by the molar mass. And remember, molar mass is the same as atomic mass, except the units of molar mass are grams per mole, not AMU. So what is the molar mass of water? Well, water's molar mass is 18, because oxygen weighs 16 and 2 hydrogens weigh 1 each, so that's 2, and 16 plus 2 is 18. So the final step is just a conversion. We are going to convert that 3.75 moles of water, that's what we had here, 3.75 moles of water, times 18 grams per 1 mole. Notice that the moles cancel. That just leaves us with grams. 3.75 times 18 is 67.5 grams of water. And that is the answer. And that is how you do a mole to mass stoichiometry. Again, I want to point out, I didn't have to start with ammonia. I could have started with any one of these. I could have, for example, started with moles of oxygen and asked you to find the grams of nitrogen. And then I would do a ratio just between the O and the N, and I would have ignored everything else. But the system is still the same. It is 2 steps. First, do a proportion to get the moles of what you're looking for, and then change those moles into grams by multiplying by the molar mass.